Hi, in the next few videos, let's understand this method called partial fractions integration. And in this method, we will be integrating rational functions essentially. And one of the key tasks in integrating rational functions is decomposing the rational functions into partial fractions. Initially, we will focus on just the method of decomposition into partial fractions. Integration generally is more or less straightforward. The main difficult task is in just decomposing into partial fractions. What is a rational function? A rational function basically is of this type. It looks like a fraction, except on the top we have a polynomial function in terms of x, and in the bottom also we have a different polynomial function in terms of x. So one polynomial function divided by another polynomial function results in a rational function. So sometimes we need to integrate functions of this type. For instance, we might be asked to integrate a function that looks like this: 8x minus 17 over x squared plus x minus 12 dx. Okay. One of the things we need to understand in learning decomposition into partial fractions of this rational function is understanding what the degree means. Okay. In this case, the top polynomial function has some degree and the bottom polynomial function has a different degree. Both of them could be same, or the degree of the top polynomial may be higher than the degree of the bottom polynomial, or in the third case, the degree of the bottom polynomial may be higher than the degree of the top polynomial. Let's take a look at some rational functions. I have jotted down here three rational functions. Let's take a look at this one here. What is the degree of the top polynomial? That's basically the exponent of the highest degree term, and that's degree 1. What about the bottom? The degree is 2. How about here? 3 and 2 for the bottom polynomial. How about here? I see 9x cubed, that's the highest degree term, so the degree is 3. For the bottom polynomial, it's not straightforward. If I do the distribution, I'm going to have the highest degree term containing x times x squared. That would be x to the 4, so the degree is 4. If the degree of the top polynomial is higher than or equal to the degree of the bottom polynomial, then we have to perform the long division even before we proceed with decomposition into partial fractions. So in this case, this polynomial, the degree of the in this rational function, the degree of the bottom polynomial is higher so no long division is required. The long division would be required only in this case. In this case, since the degree of the top polynomial is 3. So we are going to perform in the remaining part of this video just this long division. Okay. In this rational function, we earlier saw the top polynomial degree is higher than the bottom polynomial. Therefore, we will need to perform long division here. So let's do that. And the long division of algebraic expressions is very similar to what you have learned with long division of numbers in arithmetic. Okay. I'm going to write a little schematic here. For long division, I'll write the top polynomial here, 3x cubed minus 2x squared minus 19x minus 7. The bottom polynomial appears here, x squared minus x minus 6. And I need to, x squared goes into 3x cubed 3x times. So since my objective is to eliminate these higher degree terms, so that's the first thing I'm going to do. And when I multiply this bottom polynomial terms with 3x, I get 3x cubed minus 3x squared minus 18x. And just like you did in arithmetical long division, I need to subtract these terms here from the terms here. And just to make sure I'm subtracting, I'm going to change the signs here. So this would be minus, plus, plus. So now I can add. Okay, since I changed the signs, that's equivalent to subtracting. So 3x cubed minus 3x cubed would be 0, minus 2x squared plus 3x squared would give me x squared, minus 19x plus 18x will give me negative x, and I can bring down the remaining term here, which is negative 7. X squared goes into x squared plus 1 times, so that's x squared minus x minus 6. So I need to do the same thing as before. I need to subtract or add after changing the signs. So x squared minus x squared is 0, minus x plus x is 0, minus 7 plus 6 is minus 1. So therefore, this rational function can be written in this form: 3x plus 1 minus 1. See, the remainder is negative 1, so minus 1 over x squared minus x minus 6. Let me stop here. We can pick this problem up and determine what we need to do with this term where the top polynomial, which is simply 1, has a lower degree than the bottom polynomial.